Solubility rules. So we've discussed very briefly the different types of reaction. Now we're getting to the double replacement reaction. And in a double replacement reaction, you have two aqueous solutions, two solutions of ionic compounds mixing together, and sometimes an insoluble compound forms. It's called a precipitate because it kind of falls like snow to the bottom. We need to be able to predict which compounds will be insoluble. And this is not something that is just immediately obvious from the periodic table. We're going to use some general solubility rules, and these have to be memorized. You just have to memorize the solubility rules. So here are the rules. The rules are given as a list, and the order has some significance. The first rule is alkali metal ions. If a compound contains alkali metal ions or the ammonium ion, the compound is generally soluble in water. If it has acetate, it's soluble. If it's nitrate, it's soluble. If it's halide, halides are chloride, bromide, and iodide. Those are generally soluble except, so here's the beginning of some exceptions. Silver, mercury, and lead with a chloride, bromide, or iodide will be insoluble. Sulfate compounds are generally soluble except strontium, barium, and lead. So that's the list of things that are usually soluble. And then we go to the things that are usually insoluble. So carbonate compounds, usually insoluble, except for number 1. See, number 1 doesn't have any exceptions, does it? So one way you can do this, the rules here, is you start at the beginning and work your way down. If you've got something with an alkali metal in it, it's soluble. You don't have to look any further. If you have like iron carbonate, well, you're not going to find iron or carbonate in any of these rules, and so this will be the first one you come to. Carbonate compounds are generally insoluble except for that. And so this rule 1, those are exceptions to lots of things. Chromate ion compounds, usually insoluble except for rule 1. Phosphate, insoluble except for the alkali metals and ammonium. Sulfides, insoluble except for calcium, strontium, barium, and rule 1. So this table is a little different than the ones I've seen before, in which they're giving rule 1 exceptions for everything down here. It's kind of funny. And hydroxides. Hydroxides are usually insoluble except for the alkali metals and ammonium. So let's identify these 6 compounds as being soluble or insoluble, and that will give us an illustration of how to use these rules. So here we have PbC2H3O22. So we've got lead ion, and this is acetate. So we're going to look for those ions, and we're going to start at the top and work our way down. Neither of those is in rule 1, but rule 2 says that acetate ion compounds are generally soluble. It doesn't say anything about exceptions. So then we can say that lead 2 acetate is soluble. So I'm going to put S for soluble. Now, if you continued down and looked at all the rest of them, you would not find anything to contradict that, but it would take more time. Magnesium carbonate. So I've got magnesium and I've got carbonate. I'm going to start at the top and look through. No. Carbonate, generally insoluble. Magnesium is not one of those exceptions. Magnesium is an alkaline earth metal, not an alkali metal. And so this is going to be insoluble. Calcium hydroxide. So I'm looking for calcium. Calcium is not an alkali metal. It's not one of these guys. And I'm going to go through here. Nope. Carbonate, chromate, phosphate, sulfide, hydroxide. Hydroxide ions are generally insoluble except calcium. This is an exception to the rule: calcium hydroxide is soluble. Any questions about how I'm using these rules? HgBr2. We're looking for mercury and bromide. So we start up here. Nope, nope, nope. Bromide. Bromide compounds are generally soluble, except, well, this is Hg2X2. This is HgBr2. Is Hg2Br2 the same as HgBr2? No. So this one is insoluble. That's the exception that's listed, but this is not the exception, so that one is soluble. This is one that I would not give you on an exam because that one's kind of tricky to remember. Zinc phosphate. So again, start at the top looking for zinc and phosphate, and we come to that in number 8. Phosphate ions, generally insoluble except for lithium, sodium, potassium, ammonium. It's not any of those, so this one's insoluble. Ammonium sulphide. We come to that one in the first rule. Ammonium compounds generally soluble. There are no exceptions listed here. If we continue on and find sulfide, we see that the Rule 1 exceptions are soluble. And so both of those rules say that this is soluble. Any questions? These rules were determined experimentally by many people in many different places doing little experiments. Well, let's see if sodium hydroxide is soluble. I'll put some in this water and mix it up, and does it dissolve? Oh, it did. Okay, that one's soluble. And so many, many observations all put together to give us this table. Notice there's an asterisk. These compounds are actually slightly soluble or very slightly soluble in water. So here we're saying these are generally insoluble. That doesn't mean that they do not dissolve at all. They dissolve a little tiny bit. Not enough for us to worry about. They're pretty much insoluble, and so that's what we remember.